I'm Dave Bolan with Dell'Oro Group. I'm the senior analyst for the wireless packet core and the voice core for Dell'Oro Group. We're a boutique market research firm. We do network and IT and telecom research. I just have a couple slides I'd like to share with you about part of the market that I do cover. We call it the wireless packet core, and just looking at the 5-year forecast so we can see where we're going with 5G and NFV. The migration for the evolved packet core or the 4G core to the 5G core has a couple different paths that service providers can take to get to the 5G core. So on the left-hand side, we have what is traditionally been called standalone architectures. A 4G handset talks to the 4G RAN, and the 4G RAN talks to the 4G core, and likewise with the 5G. And in the 5G case, it's been known as option 2, 5G standalone. Some service providers wanted to get to market quicker. The 3GPP standards accommodated them with what we call option 3X, or dual connectivity, where I can still leverage the evolved packet core. This is the first time the industry's made a packet core forward compatible. It's always been backwards compatible, like the 4G core can handle 2G and 3G calls, but the 2G and 3G core was never made forward compatible to handle 4G calls. So in this case, we've made the evolved packet core, the standards body, forward compatible to be able to handle 5G data sessions and calls. And the most popular option is called option 3X. The text in the purple color there is the official name in the 3GPP standards, E-Ultra New Radio dual connectivity, which means a handset can be talking to 2 RANs at the same time. And in this case, in option 3X, the 4G RAN is considered the master node, and the 5G RAN is considered the secondary node. You can see, though, the control plane is being all orchestrated through the 4G side of the equation. And this gives the operators the chance to leverage their evolved packet core and not have to bring up a 5G core right away. So it actually reduces their expenses to begin with the deployment. They can get their the 5G in the ultra dense parts of their networks where they need more capacity quickly and get up and running to take care of subscribers, as we seem to have a taste for infinite bandwidth as everybody keeps using more and more bandwidth. So this is a way they could get to market faster and address that. So I'm from the US. Every US operator is implementing this way. Another step to improving the evolved packet core to get ready for 5G, which is the control plane and the user plane separation. So in the evolved packet core, they're separating the control plane and the user plane to get ready also for a distributed user plane to put it out at the edge at some point in the future. There are 2 other options that you can do for migration. You could start with option 3 and go to option 4, or you could go from option 3 to option 7, or 3, 4 to 7, or option 3 to option 2, and maybe have both of those at the same time and skip option 4 and 7. Depending on the needs of the market and what parts of the market they're going after will depend on what architecture they pick. It also depends on the timing and the maturity of the market. Like these 2 standards are not complete yet. I'm supposed to say 2018, not 2108. Otherwise, nobody would use this one. The difference is now I introduced the 5G core, and now 4G calls are routed through the 5G core, but the 4G RAN is still the master node. And over here now it's switched. Now the 5G RAN becomes the master node. Now the benefits of having dual connectivity is I get the bandwidth out of both RANs, and I can do load balancing and things like that. So there are some benefits over a pure 5G standalone. So there are some operators that are choosing this dual connectivity route because of that. China seems to be the country that's looking at 5G standalone. And some of the carriers will probably in China go with 5G standalone. Looking at the size of the market, this is in sessions, how many sessions, simultaneous attached users and data sessions that you have going. So the blue is the evolved packet core, and it's going to keep growing as we add more and more LTC subscribers. The traditional packet core, the 2 and 3G packet core will, of course, continue to decline as people migrate to the newer technologies. And then the 5G core will start picking up steam. And you can see it's picking up quite a bit in 21 and 22. And then looking at the mix of what we call non-NFV and NFV. And my definition of NFV is cloud native virtual network functions, which means you have a shared data layer, you have stateless design, you have the ability to do microservices, automation, et cetera. And there are some NFVs that are out there implemented on the Evolved Packet Core already, and it's about 20% now in the 2017, 2018 timeframe, but growing close to 90% in 2022. So if you want to be in the Evolved Packet Core business or the Packet Core business, you need to be in the NFV business. And then just looking at where's the 5G core going to be deployed on a regional basis, give you a snapshot of that. Asia Pacific is the red, that's the biggest market. North America here, and then EMEA in the middle, and then Caribbean and Latin America will have a little bit as well. So it gives you an idea of where the growth is going to come from on a regional basis.